Hi guys, and welcome to the channel. In today's video, we'll be talking about the genius 3D printers that make SpaceX rockets. Without further ado, let's begin. The private spaceflight company SpaceX wants to launch astronauts into space in the coming years, and it will enter the final frontier with an innovative technology, 3D printing. California-based SpaceX is using additive manufacturing, as 3D printing is also known, to build the emergency escape rockets on its new manned Dragon spacecraft. The capsule, known as Dragon version 2, is SpaceX's entry in NASA's competition for commercial manned spacecraft to ferry astronauts to and from the International Space Station. 3D printing for rocket engines is making a lot of headlines, and the concept of 3D printing in space has received extensive attention in industry circles in recent months. SpaceX has spent 3 years evaluating the fast-growing technology, particularly for use on the Dragon spacecraft. A 3D printed Super Draco engine chamber, which will be used in the escape system, passed a firing test at full thrust in late 2013. The development of both Merlin and Super Draco engines was crucial to the evolution of the company's spacecraft. The Falcon 9 rocket, set to take Benken and Hurley to orbit today, is powered by 9 Merlin engines that are gradually throttled near the end of the first stage flight to limit launch vehicle acceleration as the rocket's mass decreases with the burning of fuel. While the Dragon capsule, which is the pressurized section that will transport the crew, is equipped with Draco thrusters that allow Dragon to maneuver while on orbit, 8 Super Dracos are coupled together as a launch escape system. This is crucial to the mission, considering that, should a major malfunction be detected, the computer is programmed to instantly fire the Super Dracos, blasting the capsule away from the Falcon 9. It has been a very successful existence for SpaceX so far. After almost 20 years of developing space hardware, the company has only hit a few bumps along the road. Since June 2010, rockets from the Falcon 9 family have been launched 87 times, with 85 full mission successes, 1 partial failure, and 1 total loss of spacecraft. This Crew Dragon Demo 2 mission was originally planned for launch in July of last year, but the Crew Dragon capsule from the Crew Dragon Demo 1 mission was destroyed during static fire testing of its Super Draco thrusters. Still, the Falcon 9 rocket has officially become the most flown, currently operational U.S. rocket. High-performing rocket parts can be created using 3D printing and offer improvements over traditional manufacturing methods. SpaceX is pushing the boundaries of what additive manufacturing can do, hoping to make the Falcon 9 rocket and Dragon spacecraft more reliable, robust, and efficient than ever before. In 2014, SpaceX launched its Falcon 9 rocket with a 3D printed main oxidizer valve, MOV, body in one of the 9 Merlin 1D engines. According to the company, the mission marked the first time SpaceX had ever flown a 3D printed part, with the valve operating successfully with high-pressure liquid oxygen, under cryogenic temperatures, and high vibration. SpaceX claimed that compared with a traditionally cast part, a printed valve body has superior strength, ductility, and fracture resistance, with lower variability in materials properties. The MOV body was printed in less than 2 days, compared with a typical casting cycle measured in months. The valve's extensive test program, including a rigorous series of engine firings, component-level qualification testing, and materials testing, has since qualified the printed MOV body to fly interchangeably with cast parts on all Falcon 9 flights going forward. If you're enjoying the video, then hit the like button and smash the subscribe button. SpaceX has also revealed details about its use of 3D printing in the Super Draco thruster engine for the Dragon spacecraft, as well as in one of the Falcon 9 rocket's engines. The Super Draco rockets are designed primarily as an emergency launch escape rocket in the unlikely event the first stage of the rocket fails explosively. These rockets need to accelerate the crew capsule with an incredible thrust of 120,000 pounds in order to safely escape the blast. The engine chamber of the Super Draco was 3D printed out of Inconel, a super alloy used in the aerospace industry for high-stress parts. This component was put through a variety of tests such as multiple starts, high temperature, and extended firing durations, to name a few. These tests proved that the engine chamber was ready for use on a Dragon 2 capsule rated for human flight. The Super Draco thruster engine is an advanced version of the current Draco engine that's used in SpaceX's Dragon spacecraft to maneuver in orbit and during re-entry. Super Dracos will be used on the crewed version of the next-generation Dragon version 2 spacecraft. There, they will power the vehicle's launch escape system, which is completely integrated into the spacecraft. The company also successfully fired the engine chamber at full thrust, which is 16,000 pounds per engine. Now, SpaceX is testing these engines in its crewed spaceflight program. Using 3D printing reduced lead time by an order of magnitude compared to traditional machining. From the first concept to the first hot fire test took slightly more than 3 months. SpaceX revealed that prior to the use of additive manufacturing in fabricating the engine chambers for the Super Draco, they had 3D printed another important engine component, which was used within the launch of the Falcon 9 rocket back in January of this year. The 3D valve inside the Falcon 9's rocket engines will also be more efficient to manufacture, SpaceX added. After extensive testing, the 3D part is now certified to fly alongside regularly manufactured materials. The body of the main oxidizer valve within one of the 9 1D engines found in the Falcon 9 rocket was 3D printed. For those who are not rocket scientists, the main oxidizer valve is the valve that controls the flow of liquid oxygen as it enters the main combustion chamber within the engine. A faulty part could be catastrophic for any launch. The technology which is used for 3D printing is known as direct metal laser sintering, DMLS. So let's have a look at what is DMLS and how does DMLS work. Direct metal laser sintering, DMLS, is an industrial metal 3D printing process that builds fully functional metal prototypes and production parts in 7 days or less. A range of metals produces final parts that can be used for end-use applications. The DMLS process builds a part from an STL file, meaning that it slices the part into layers, similar to all the laser-based additive manufacturing techniques. This process uses a high-power laser for sintering the metal powder. At the start of the process, a steel build plate is set inside a build chamber where there is less than 1% of oxygen and the atmosphere is controlled with an inert gas. This helps prevent the oxidation of metal powders during the building process and preserves the metal at an optimum quality, as well as decreasing fire hazards and making the final product inert. During the building process, the build platform is lowered 1 layer of thickness so that the coating mechanism, also known as the recoater, can move without collision. The coating mechanism distributes the metal powder evenly through the build platform, and the laser beam through a 2-dimensional cross-section selectively sinters the powder into solid. This process of lowering the build plate of 1 layer thickness, the coating mechanism dispensing a layer with powder, and the laser sintering it is repeated until the part is completed. Once the part cools down, the removal of the surrounding powder, which can be reused, follows. The final steps include removing the part from the build plate, support structure removal, as well as any required post-processing. So guys, let me know down in the comments section below, what do you think about these amazing 3D printers that make SpaceX rockets? For more interesting content, give this video a thumbs up and don't forget to subscribe to the channel for more awesome content. Have a nice day, and I'll see you on the next video.